Hello everyone, welcome to the channel. Before we start the practical commands, let's briefly understand what Git and GitHub are. Git is a version control tool that works on our computer. It keeps track of changes we make to our project files. GitHub is an online platform where we can store our Git repositories. So, Git and GitHub are related, but they are not the same. Git tracks changes on your computer. GitHub stores and shares your Git project online. The basic workflow is very simple. Edit, add, commit, push. We edit our files, use Git to track and save the changes, and then push those commits to GitHub. Now, let's start with the practical steps. To install Git, open your web browser and visit the official Git website. This page provides separate installation options for Windows, Mac OS, and Linux. Select the tab that matches your operating system. After installation, verify Git by running version. If Git returns a version number, the installation is complete. Open your web browser and visit. If you do not already have an account, click sign up and create one using your email address. Choose a professional username because it will become part of your GitHub profile link. For example, my GitHub username is IANTextaholic. Before making our first Git commit, we must tell Git our name and email address. Git records this information with every commit. First, configure your name, now configure your email address. Replace these examples with your own name and email address. For this demonstration, I will create a simple bioinformatics project containing an R script and a README file. Now, I will create a new directory for our project. Our new project folder is named Bioinformatics Hit Demo. Touch command creates new empty files. The R extension identifies an R script, while MD means Markdown, a simple formatting language commonly used for GitHub documentation. Now, I will open the R script using the vtext editor. Now we are inside the analysis R file using the vtext editor. For this demonstration, I will create a very small gene expression dataset. First, press the letter I to enter insert mode, which allows us to type inside the file. First, I will create a vector containing 3 gene names. Next, I will create another vector containing the log2 fold change values. Now, I will combine these two vectors into a data frame. A data frame organizes information into rows and columns. Each row represents one gene, while the columns contain the gene name and its log 2-fold change value. Finally, I will print the data frame. We have now created and saved our first R analysis script. I will display the contents of the R script directly in the terminal using cat command. Now, I will open the README file. A readme.md file explains what the project is about. When we upload this repository to GitHub, the README will automatically appear on the repository's main page. Now we are editing the readme.md file using the vtext editor. Now I will convert this ordinary folder into a Git repository by running. The word init means initialize. Next, I will check the current condition of the repository. The output shows branch main, no commits yet. On branch main means that we are currently working on the main development branch of the project. No commits yet means we have not saved any version of this project in Git. An untracked file is a file that exists inside the project folder, but Git is not yet monitoring it. An untracked file is a file that exists inside the project folder, but Git is not yet monitoring it. Now our folder is a Git repository, but the project files are still untracked. The git add command tells Git which files should be included in the next commit. Next, I will check the repository using git status. Files are staged and ready for our first commit. The file names usually appear in green to indicate that they are in the staging area. Now I will create the first commit. Commit is a saved snapshot of the project at a particular point in time. The M option allows us to provide a short message describing the changes included in the commit. Good commit message should be short, clear, and explain what was added or changed. After running the command, Git displays information. This confirms that Git successfully saved both files in the first commit. Finally, I will view the Git history. Git log command displays the repository's commit history. One line option presents each commit in a short and readable format. Output includes something similar. First part is the abbreviated commit ID. The second part is the commit message that we provided. Head, main indicates that we are currently viewing the latest commit on the main branch. Our first local Git commit is now complete. However, the repository currently exists only on this computer. I am going to GitHub and selecting New Repository. Under repository name, I will enter Bioinformatics Git demo. GitHub asks us to choose the visibility of the repository. If I select public, anyone on the internet can view this repository and its files. Now I will leave these initialization options unchecked and click Create Repository. GitHub has now created an empty repository. On this page, GitHub provides the commands we need to connect an existing local repository. On GitHub, select HTTPS and copy. Now I will connect this local Git repository to the GitHub repository. Next, I will make sure our primary branch is named main. This command sends our local commits to the main branch of the GitHub repository. GitHub needs to verify that we are actually authorized to upload files to this repository. There are two common ways to authenticate Git from the terminal: HTTPS and SSH. HTTPS is generally easier for beginners. If Git asks for a password, you need to use an approved authentication method, such as a personal access token, also called a PAT, or authenticate using GitHub CLI or a credential manager. A personal access token works like a special password created specifically for accessing GitHub from applications or the command line. Never show or share your token because it should be treated like a password. The second option is SSH. SSH uses an repository URL and requires an SSH key connected to your GitHub account. On a Mac, I can copy the public key using pbcopy. Then, on GitHub, I go to Settings, SSH and GPG keys, select New SSH key, and paste this public key. Hostname github.com specifies the GitHub server. Now let us check whether the SSH authentication is working. When I run this command, GitHub responds, "This is actually a success message." Now that SSH authentication is working, I will change the remote address of our repository to use SSH. Next, I will make sure that our main branch is called main. Finally, we are ready to upload our project to GitHub. After making and committing new changes, we normally only need to run git push. We have successfully configured SSH authentication and pushed our local Git repository to GitHub. Now let's go back to GitHub and confirm that our project was uploaded successfully. We have readme.md, which provides information about the project, and analysis, R, which contains our R analysis code. Now I'll return to the terminal and run git status. Your branch is up to date with origin main. Let's quickly recap the main Git commands we have used so far. We confirmed that Git was installed using Git version. Next, we configured our identity. Then we created a project folder. Once our project was ready, we initialized Git. Next, we added our files to the staging area using Git add. After staging the files, we created our first save point using Git commit. To view that history, we used Git log. Finally, to put our project online, we connected our local Git repository to GitHub using Git push. Thank you very much for watching. Please leave your comments and subscribe to the channel for the next Git tutorial. See you in the next video.